So today we are doing lesson 10.1 extension, which is on how to rationalize the denominator. And so what that means is our goal is to have no irrational numbers, in the denominator. Okay, so an irrational number is a number that doesn't end or repeat as a decimal. So pi, that's an example of an irrational number. Or square root of a number that's not a perfect square. These numbers do not end and they do not repeat. So sometimes we're going to have a denominator that is a monomial. And sometimes we will have a denominator where it's a binomial. So when we have a denominator that's a monomial, it's kind of easier. So let's say we have 1 over the square root of 10. And we want to basically make this denominator a perfect square so that we can get a number that will reduce. So we want perfect squares to be inside the radical for the denominator. So if I multiply 10 by square root of 10, so square root of 10 times square root of 10, well, that will give me the square root of 100, and I can simplify that. But I have to remember that what I do to one, I have to do to the other side, because I don't want to change the value of this fraction, I just want to change the appearance. So this right here is multiplying by 1, because it's the same thing over the same thing. So then 1 times square root of 10, technically that's a 1 times root 10, because this 1 is not inside the radical, it cannot multiply by the inside, but generally we don't write the 1, so that would just become root 10. Now the square root of 100 is 10. Now because one number is inside and one number is outside, we cannot reduce these, so we are actually done with this problem. Now, another one is, let's say we have the square root of 3 over 12. There are many different ways that we can approach these, so I'm going to go through a couple of them. So we could go ahead and simplify 3 over 12 to make that square root of 1/4, which is, we can square root that and we can get 1/2. Or we can take a middle step and go square root of 1 over square root of 4 will also give us 1/2. Okay. But maybe the original problem didn't have it all under one radical. Maybe it was the square root of 3 over the square root of 12. And you would have to rationalize that denominator. So a perfect square would be 36. So if I multiply by square root of 3 over 3, then I can get square root of 36 on the denominator. Square root of 3 times square root of 3, they're both inside the radical, so I can multiply. Square root of 9 is 3. Square root of 36 is 6, and that still reduces all back to 1/2. So sometimes there's one way to approach it, and sometimes there's multiple ways. Now, what if we have a denominator that instead of it being a monomial, it's a binomial? Then we have this thing called a conjugate. And I want you to think of when we had x plus 2 times x minus 2, when we multiplied those, then we ended up saying, well, because it's the same thing on the inside, just with different signs, our middle terms are going to cancel and we get x squared minus 4. So we're going to use a similar idea for this. So let's do a quick example where we have 1 over 5 plus the square root of 3. So my conjugate to this would be to take that denominator, keep everything the same except for I'm going to change that sign to be a negative instead of a positive. And again, what I multiply to the bottom, I must do to the top so that I'm not changing the value, only the appearance. So when I distribute this top, 1 times 5 is 5. And 1 times negative root 3 is negative 1 root 3. Again, I'm writing the 1 just so you can see I'm not multiplying the inside, I'm only multiplying the outside. And then just like this, I'm going to go ahead and expand out and say that, well, 5 times 5 is 25, and 5 times that is negative 5 root 3. And if I do the same thing with this, then I get plus 5 root 3 and minus, well, these two are both inside the radical, so I can multiply 3 by 3 to get 9. So just like here, our middle terms were plus 2x and minus 2x, and they canceled out. Well, these two will cancel out. The other benefit of this is we now have the perfect square inside this radical. So this is actually going to become 25 minus, because of this sign right here, and square root of 9 is 3. So the top stays 5 minus root 3, and the bottom is now 25 minus 3, which is 22. Now, I don't have any other like terms between these, so I'm done, and that is how you would reduce that. So using the conjugate, it'll create this denominator here, and it would have 4 terms, but the 2 middle ones cancel. And it will create this last term will be the square root of a perfect square. That's it for today's notes. Let me know what questions you have when you get to the homework.